Okay, welcome back. So let's continue the series where we are basically making some 2D ray tracing with reflection. I mean that is our end goal. So far we just have our light source and we can move it around, but it's not really what we want, right? So today um, this time we are going to create a class for the rays and we are going to draw them. So if by the end of the video we just have the class for a ray, and a ray is just going to be basically a line that goes from here's the side of the circle, the disk, to um, well the end of the window. So far we don't have any obstacles. In the window, but at some point we are going to add some, and so we will have to take into account collisions with these obstacles. So yeah, I mean a ray is basically going to go from, so let's see, paint is our best friend. So a ray is going to basically have 2 points, so the center of the disk and a point here on the side of the disk, on the perimeter here. On the border of the disk, and so basically it's going to go here. This one is going to go this way, but it's only going to really start displaying from once it's on the surface of the disk, right? It's not going to display inside. I mean, we can do so if we give a radius of 0 to our disk, but yeah, I mean, we just want the rays to come out from outside of the disk this way. So let's do this. I've done a little bit of research on my own because I couldn't stop thinking about it. So I did a little bit of research on my own in order to calculate a few things, and I also came up with an algorithm to calculate the coordinates of the point at which the line should stop. For example, we have our window here, and we have here our disk. So the light ray is going to go here, but how do we calculate the coordinates of this point, right? Of the border of the window here? Well, it's actually pretty simple. I will explain some more later, but basically the problem here is that we have only the center point here and this point here. So first, we need to know how to draw a line that goes in this direction. And to do so, we need to calculate the angle between this and this, which we will call alpha. And so this is an angle. And secondly, once we are able to draw the line here, how do we get the condition to make the line stop from being drawn once it reaches this point? Well, that's what I'm going to explain later on, once I will have to. Okay, so let's begin. So let's remember, so far we just have this. Let's make a ray class. So I'm going to call it ray, and a ray is just going to have two private attributes. Yeah, or maybe 3 for the color. Yeah, let's make it 3 in order to have the color. So it's going to have SDL point 1, so the origin. Let's call it origin, and another point. Let's just put it here actually. Origin and P1. So basically, if we look at this drawing, the origin is going to be the center of the disk, and P1 is going to be like the point on the surface of the disk. Like not on the surface, but on the perimeter, or yeah, like the border of the disk. Right. Now it's also going to have an angle. So I'll explain some more later. I mean, it's the same angle that I talked about here. Like it's going to be this angle, but it's not the user that's going to set the value of the angle. It's going to be the class itself, like when it's created, and when one of the points starts moving, or like when P1 moves, basically the angle is going to change. Like if P1 goes from here to, I don't know, like if P1 goes from here to, I don't know, like here, then the angle is going to move to here, right? And alpha is going to become this value. And so yeah, we are eventually going to write this. Let's see. So double angle and also a color. So since we are going to use the same set render draw color here, the same function, we are also going to have RGBA, so 4 channels. So let's just copy and paste this here. Right. So now when we're going to create an array, let's see. So right now I'm just going to try to create an array that for which I'm going to give 2 points. So SDL point O and SDL point how should I call it, P. Let's just do it this way. Nothing else. I mean, I'll do the same thing here. Well, I'm gonna do set color afterwards, but by default it's just going to be white. So origin is going to be O, P1 is going to be P. The angle is we are going to calculate it right after. Or actually, I'll just do it right now. So basically, yeah, the angle we want to have is so this value, and basically, if we do trigonometry, there are many ways for us to get this angle. Basically, so if we look at, so I'll just do a drawing here below. So we have here y-axis here, x-axis here. I know that in our case the axis actually looks like this for y, and oops, what did I do? Oops, still a little bit too thick. Yeah, this is fine. So like x and y actually look like this in our case, but it doesn't matter. Just for the sake of the example, I'm going to show it this way, the normal way. So if we have a line that goes like this, and we have our alpha angle here, well, how do we calculate it if we have 2 points? So we have this point, which in our case would be like the point here in the border of our disk, and we have the center of the disk right here. Well, this distance, and this distance, we know them. So we know here this is a radius. This is I don't know, like let's call it y1, and this is x1. And basically we have many ways of calculating. Or actually, let me come back here. So this point is x2, y2 in terms of coordinates, and the coordinates of this point, it's x1, y1, right? And so basically this value here, so this distance here, it's just y2 minus y1, right? And this value here, this distance, it's actually just x2 minus x1, right? So if we take so relative to the entire window, like if we draw all of this within a window, we'll look at the value of x2 here. So x2 is all this goes until here. This is where x is equal to 0 here. And so when we take x2 and we subtract x1, x1 is this value. Well, what we get is this distance, which is what we are looking for. And so same thing for y2 minus y1. And so if we look at trigonometry, basically here alpha, what we get is that so if we look at trigonometry, we have a tangent. So tan of alpha is equal to so the opposite side here, so y2 minus y1 over here x2 minus, so the adjacent side. Right, so this is just trigonometry, and so if we want to get alpha, we have to, I mean, we can apply the inverse function of tan equal to alpha, which is in itself equal to all of this. Let's just put it here. Oops. Oh, my bad. I think you get my point, but I'm still going to put it here just so that it's clear. Okay, basically, so it's like this cancels itself. This and this, they cancel each other out. I think this is true for each value, but the other way around, like tan of arc tan. I don't think it cancels. I don't know if it's my memory, but yeah, it depends on like the. It depends on, I don't know how to say it in English, but like yeah, it depends on in which values. It depends on the values of alpha, like here. But here, since tan is, let me see, tan is not defined for every value. No, I think maybe. Yeah, I don't know. I'm not sure. Maybe with tan between -1 and 1, this is always defined. And anyway, it is not a math class, so. But so I could do this. So I could do this in the program, but apparently there's a very convenient function that we have in C++ called atantu, which gives us exactly that. So it's going to give us the angle in radians, and so we're just going to use this. And so in the constructor here, we're just going to initialize angle as atantu of, so y is going to be, as we said, is just going to be, let's see, p1 x minus origin, or let's just do px minus ox, and the x value is just going to be the x value is, oh wait, I'm getting this wrong. Right, and so and also this is wrong because since in our case we are basically like here in terms of y evolves in this direction and x goes this way. So when we do, so we should do here, when we look at this, if we want to get a positive value for the height, we have to do first, we have to do like the y value of this point minus the y value of this point, and not the other way around. So here it should be o.y minus py, and then it's going to be px minus ox, and so this should give us the angle. I'm going to check afterwards. I'm going to print it in the console. And then so we have this, and then we're just going to put the colors to white by default. Let's just copy all this actually. Okay, right, so we can just do that. I'll just copy as well this as well, because well, we don't really care, like it doesn't bring us anything to not copy it here. Okay, now what we're going to do is, so we have a ray, so a ray, and we want to draw it, so we're just going to call the draw function. We are going to create a draw function, and it's going to be const, and let's just do it here, void ray draw const. Right, so I forgot something here. It should be we should give it the renderer as an attribute, as a parameter here, SDL renderer. Okay, cool. Nice. Okay, so let's stop here for now. Let's just make sure that this gives us the right thing. So I'll just make it print the angle whenever we create a ray. So let's see. So if we go over here, let's create a few rays. So ray art1, and we'll give it so 2 points, right? So I think the 2 points we can just give them between curly brackets. And so let's do 400 400, since that would be the middle of our window. And let's do 400 350. Here I'm just going to check for the sine of the angle that we are going to get, and ray R2 is just going to be same thing, but here 400 450. So if we look at the 2 points here, basically the ones that I'm creating here, they are so if this is the center of the window, I'm creating one here and one here, and so I'm expecting the first one here to be pi over 4, and the second one to be minus pi over 4. I hope that's what we are going to get. Let's see anyway. So the values here, pi over 4 minus pi over 4, it's just trigonometry. I'm not going to bother explaining everything because I wouldn't be able to. I don't have everything in mind. Right, so we have pi over 4, oh, it's pi over 2 actually. Wait, did I do the wrong thing? Yeah, my bad, I didn't do the right thing. So my thing works, like what I did, it works, but it's just that I forgot to add 450. Basically the points that I had created here were actually here and here. So I got pi over 2 for this and minus pi over 2 for this, but so here I'm gonna get pi over 4 first and then minus pi over 4. So let's close this, let's run it again. Now I'm going to get pi over 4 minus pi over 4. Great, that's what we wanted. I'm not going to leave this here, or actually maybe I am, never mind, because then I'm going to use them later to draw them on the screen, to render them. So that's pretty neat. So I can remove this, it seems like it works perfectly fine. Okay, so now in order to draw, let's see, how do we draw this? Well, this is where the algorithms that I came up with earlier is going to come in handy. So let's show more about it, because I had an output window here. Alright, this way. Okay, so basically I basically created a window width and height just like we have here. Created a point structure, which is just like SDL point basically, but it's just, yeah, homemade. And so I created a first pixel in the middle of the window with an arbitrary angle, and just wanted to see if the algorithm worked to like calculate the point at which it should stop drawing, like when it's at the edge of the window. So like, for example, if we have the first point here, second point here, so we have basically our source of light here, and so it started from here and then it calculated like the point here until it detected that it was at the edge of the window. And so basically I initialized my first pixel here. So the first pixel would be the pixel here, so it would be our P1 here, not origin. We're not going to use origin anymore. So I wrote here 400 400, but it's a bit misleading. Maybe I should do like I don't know, like 390 and I don't know, whatever I should do here, and like 483. Let's just do that. And so this would be 483 would be our point here, and pixel 2 is the pixel that we are trying to calculate. Basically, we are trying to get to this point. And so I started with a distance of 2, and by that I mean that the next basically I'm going to draw each time a small line. I'm going to check if there's a collision. I'm going to draw a bigger line, check if there's a collision. Draw a bigger line, check if there's a collision. Bigger line, check if there's a collision. Like if it's at the edge of the window. Continue until basically I'm here, and here there's a collision. So it's not the most efficient, probably, I know, but it works, I hope. And it's going to do the job for us, I think. And if there's a really better way to do it, like very better, way better, way more optimized way of doing it, maybe I will implement it, but not right now. Okay, so basically so this is distance that gets incremented each time. Then I created two booleans. I didn't have to, but just for the sake of readability I did. So here is going to check if the x value of our point, so if we look at here, if we look at this here, the x value of this point is this distance, right? Or rather, it's just this way. This is x, and y is and y is this value because it starts here at the origin. Right, and so now, so this is for x and y, and now I'm going to add to pixel 2. So I mean, it's not I'm going to add, but the x value of pixel 2, so the point we're looking for, is going to be equal to the x value of pixel 1. So basically we are creating a new pixel. I'm going to draw it in red, and we're going to place it right here, so next to the one at which we started, and the x value is going to be, so the x value of here plus a certain quantity, and this quantity is r times the cosine of the angle. So in our case here, so r is going to be 2, which is very small, so it's going to be like 2. For example, this is 2 in terms of distance here, and cosine of the angle. So here our angle is basically this, and the cosine is basically like a very small value because we need to like it's between -1 and 1 cosine, and so it's going to be 2 times a certain coefficient between -1 and 1. In our case, since the angle is here, cosine is going to be negative. It's going to be something like I don't know, let's see, I don't know, like something like square root of 2 over 2, which is I don't know, about 0.7, something like that. I don't know, and so this red line is not going to be as long. It's going to get a bit shorter. So this is going to be our new x value. So in reality, it's just going to be it's going to become this instead of a bit longer here. And same for the y value. Basically, we're going to look at the sign instead. So the sign is going to be this. The y value is going to become this. And so if we look at this, if we draw it, we go from basically here to here. And then we're going to repeat the process each time. So we do the modifications here, the changes here, and then we check that it's still that the point is still within the window, and if it isn't, then we basically finish. Like we're done. We have the coordinates of the endpoint, and then we will just have to draw the point. Right. So this was a bit. So I feel like this session, this episode is just going to be a lot of explanations. And yeah, here I printed out like all the iterations, and it stops here because y becomes 1. Yeah, and the angle is pi over 3. So in this case, in the case of the example here, it was actually going in this direction. So it actually met the top of the window first. Okay, let's actually code now. That's what we are here for. I mean, that's why I'm here, at least. So I'm just going to look at the thing I wrote, just to do this a little bit more quickly. So I'm going to create SDL point pixel 1 is going to be simply equal to. Actually, I don't need to do that. It's just going to be P1. Pixel 1 is just going to be P1, and the angle will also have it. So let's just do SDL point P2. Let's just call it P2. Why not? It's just going to be equal to -1, -1. This is how I'm going to initialize it. It's outside the window, so it doesn't matter. R is going to be equal to 2, or actually I'll just call it distance equal to 2, and now I'll do my two booleans. So xok equal to false, and yok equal to true, and what am I saying? False. And while let's to make it more explicit, while this is equal to false and y OK equal to false. So basically, while I mean, I don't really know how to have to explain, but basically, while neither the y value or x value of the new point are at the edge of the window, so like here or here or here or here, then we are going to continue. And once we reach an edge, that's when we stop. And so here let's just wait. Okay, it's just because the paint was right behind. So basically, p2x is just going to be equal to p1x plus r times STD cosine of our angle, and so p2y is going to be equal to p1y, and this is actually not going to be a plus but a minus. And why? Well, that is because we are in this representation, and so normally it would be a plus sign if we were in this representation, but since here we are like this, then the value of sine is going to be the opposite of the values that we would normally have if we were in this representation, because like the sine of here's this value is just the opposite sign of this value. It's just a negative version of it, negative. So that's why I'm using a minus here in order to counteract this. Since our angle here is basically defined as positive and going in this direction, I'm just counteracting this by adding a minus here. So I hope that makes sense. So here I'm just going to do the condition. So if p2x is below or equal to 0, or p2x above or equal to window width, then x OK will be true. And if p2y below or equal to 0, or p2y above or equal to window height, y OK will be equal to true. And then we're basically going to get out, but we need to wait, I said R, but I'm not being serious, am I? I was just looking at the right screen, that's why. So this is distance, and so distance, we're just going to increment it afterwards. So now that we have our point, so we have our coordinates with our point. Now let's just draw. So SDL set render draw color to RGBA, and here SDL render draw line, and so it's just going to be render x1, so this would be p1x, p1y, p2x, p2y, right? So I think that should do the trick. I hope it does. So if I go here and do R1 draw render and R2 draw render, let's look at the 2 points. Okay, so let's see if that works. Oh god, it does. I'm so happy. Oh my god, because like when I was thinking about it while eating dinner, I was just like, if this works, I'm gonna be like so proud of myself. But okay, good. I know it sounds like I'm not very excited about it, but I promise that I am. Okay, I tend to have a pretty monotone voice, so yeah. Let's just see if this works as well. God, this works perfectly. Okay, good. Well, we are about to reach the 30-minute mark, so I'm going to stop the video here, and in the next video we are just going to basically add the rays to our light source. We're going to make it possible to have a certain amount of rays to our light source, then display them, and then be able to move around the light source with the rays attached to it. And then we are going to add obstacles. I think we can do this in the next video, all of this in 30 minutes. Alright, thank you for watching, and I'll see you very soon. Goodbye.